Welcome back. This is the second lesson recording for IM2, January 28th, 2021. So y-intercept from factored form. How do we find that? Well, we know that y-intercept is going to be this point here, and it's always going to have the coordinate of x comma something, and we know that at any y-intercept, the x coordinate is going to be 0. Okay, it doesn't matter whether it's crossing here, or it does not matter. The x coordinate is always going to be 0. So we're going to use that fact and substitute x to be 0 into our original equation to figure out what the y is. So that becomes y is equal to 0 minus x. Wherever I see an x, I replace it with a 0. 0 minus 1 multiplied by 0 minus 3, and that becomes negative 1 multiplied by negative 3, which is positive 3. So I have just figured out that the y-intercept in this graph is 0, 3. What about the Wolof multiplier? Last lesson, we explored the Desmos graphing calculator and graphed different versions of 2x minus 5 multiplied by 10x plus 1 by putting a different number for the multiplier here. And we found that it vertically stretched or compressed the parabola. So for example, if you multiply by a number, if the multiplier is bigger than 1, then it stretches the parabola. It's almost as if you're pulling from the top and the bottom and pulling it apart, and so therefore forms a much skinnier parabola. However, if you multiply the same factored form, but if the multiplier is 0.5, a number less than 1, that means you are going to compress or make a fatter, more opened up horizontally parabola. Another thing the multiplier does is it, depending on the sign sign of the multiplier, if it's positive or negative, it decides whether the parabola is going to be opening up or down. So if the multiplier is positive, then the parabola will open up and form a happy face parabola. Whereas if the multiplier is negative, the parabola will open down and form a sad face parabola. So for example, we're multiplying by 2 here. Multiplier is positive 2, and the second one, multiplier, is positive 0.5. Okay, so they're both going to be a happy face parabola because they are both positive. The numbers are positive. So, but the first one is going to be much skinnier version of the second parabola, though, because 0.5 has compressed it. However, if I multiply it by negative 2 or negative 0.5, it flips the parabola downwards. So it is now opening downwards, or it's a sad face parabola. Okay, all right, so then let's put everything together and figure out how do we find all the different key attributes of quadratic function, quadratic equation. Okay, so if I have this equation, negative 2x minus 1 multiplied by 2x minus 7. The first thing is, you should be asking yourself, is the graph going to be opening up or down? What is the multiplier? That is the number in front of the parenthesis. In this case, there is no number. But what is that number when it's not really there? The default is always 1, because 1 times anything, 1x, you just don't write 1x, but the default is 1, right? So this is not just 1, but this is negative 1. It's being multiplied to the factors. So then this is less than 1, or it's a negative number. I'm sorry, it's a negative number, so it's going to be a sad face parabola that's opening downwards. What are the x-intercepts? How do we figure out the x-intercepts? We know that y-coordinate is always going to be 0, so we set the equation of y value to be 0, and then we separate the two branches of the factors. 2x minus 1 is equal to 0, 2x minus 7 is equal to 0. We're using the zero product property, and then you're figuring out what is the value of x that makes this equation true, and so it's 0.5 and 3.5. How do we figure out the y-intercept? Well, y-intercept's x-coordinate is always 0. We're going to use that fact and substitute x to be 0 into our original equation right here. And that will give us 2 times 0 just becomes 0 minus 1 is negative 1. 2 times 0 again is 0 minus 7 is just negative 7. So negative 1 times negative 7 is positive 7 times another negative, so it's negative 7. Okay, now what about the vertex? How do we figure out the vertex? Vertex is always the average of the x-intercepts, so we're going to take the average of those two and divide by 2, and you get 4 over 2, which is just 2. So that's the x-coordinate of the vertex. Now that I've figured out the x-coordinate, then I can figure out the corresponding y-coordinate for that point. So you plug 2 into our original equation for x, and then you get 2 times 2 minus 1 in the first parenthesis, 2 times 2 minus 7 in the second parenthesis, all multiplied by negative 1. So that becomes negative 4 minus 1 is 3, 4 minus 7 is negative 3, so it is positive 9. So I know that y-coordinate of vertex is 9. So the vertex coordinate is 2, 9. What about the line of symmetry? Since we know that the line of symmetry always goes through the vertex, okay, and it goes through the x-coordinate of the vertex. So we use that fact and say that its x is equal to 2. Okay. Alright, what about working with standard form? If I have a quadratic equation written in the standard form like negative 2x squared plus 8x minus 3, which attributes can I find out relatively easily? Can we figure out whether it's opening up or down, the vertex, the line of symmetry, or the y-intercept, or the x-intercept? What's easy? Well, with the standard form, the easiest part about standard form is the y-intercept is super duper easy. Okay, remember that's just a constant because the y-intercept, the x-coordinate of the y-intercept is always 0. When you substitute 0 into the equation, the first two terms become 0, so you're just left with the constant term. So y-intercept is easy. The x-intercepts are a little bit more tricky depending on whether the quadratic expression is factorable or possibly it doesn't have any x-intercepts at all. So it can be easy because sometimes the expression is factorable, and we have so far given you lots of factorable quadratic expression, but like I have mentioned before, many if not most of our quadratic expressions are not necessarily factorable. Okay, that means it's not some whole numbers that multiplies to but it might be a fraction or it might be a rational number and so on. And later on, we're gonna learn how to find those x-intercept when it's a little bit more complicated. But for now, we're just going to be focusing on factoring, converting the standard form to factored form to find the x-intercepts. What about whether it's opening up or line of symmetry or the vertex? Okay, there's three things. These are the ones that we are going to be learning or exploring today. Okay, so let's look at the attributes from the standard form. It's always going to be written in ax squared plus bx plus c is equal to y. So when you look at a, what is the value of a? That's actually going to decide whether it's going to be opening up or opening down parabola. If a is positive, then it's going to be opening up. If a is negative, it's going to be opening down. Just like the multiplier in factored form, right? If the number that is right at the beginning, if that is positive, it opened up. Same thing here. If the number right in front of the x squared is positive, then it's going to be opening up. If it's negative, it's going to be opening down to a said parabola. The y-intercept is always c, we've said that. And to calculate the x-coordinate of the vertex, okay, so x-coordinate of the vertex, okay, if you have figured out the x-intercepts, because the equation is easily factorable, then you know how to figure out the x-intercept. Another way from the standard form to be able to figure out the x-coordinate of the vertex is using this formula x is equal to negative b over 2a. And this is a formula that you're just going to have to memorize. So x is equal to negative b over 2a. And to calculate y-coordinate of the vertex, substitute the x-coordinate into the equation. So let's go through that as an example here. Okay, so you have y is equal to negative 2x squared plus 8x minus 3. So we're looking for the vertex, and the vertex is always going to have the coordinate of some x value and some y value. Okay, so you need to find the x value first. And we said the equation, the formula is negative b over 2a, where a, b, and c refers to, so ax squared plus bx, so y is equal to x squared plus bx plus c. So that means that this is our standard form of quadratic expression or equation. So that means the number in front of the x squared is a. So I can write that a is equal to negative 2 in this case. What about b? b is equal to, what is the number that is multiplied to x? That's 8. What about c? What is c in this case? c is not 3, but it's actually negative 3. Do not lose that negative signs there. Okay, because if you lose that negative sign, you're going to have a very different number. Okay, so from here I have the negative sign from the formula, and then b is just 8, and then 2a, 2 times a in this case is negative 2. So I am dealing with negative 8 divided by 2 times negative 2 is negative 4. Negative 8 divided by negative 4 is positive 2. So I know that x coordinate of the vertex is 2, so I can put that in. But I do not know what the y coordinate is yet. However, I do know that the point goes through this parabola, so I can substitute x is equal to 2 to y is equal to negative 2x squared plus 8x minus 3. Okay, so then negative 2 times 2x squared plus 8 times 2 minus 3. Now order of operation is really important. I am going to do the exponents first because exponents are higher order. 2 squared is 4. 4 times negative 2 is negative 8. 8 times 2 is 16. So then subtract 3. Negative 8 minus 3 is negative 11 plus 16 is going to be positive 5. So I know that the y value is going to be 5 and x value of the vertex is going to be 2. So I can figure out the vertex as 2, 5. So let's put everything together from standard form. If I'm dealing with negative 2x squared plus 8x minus 3, first thing is, does the graph open up or down? I am going to say I look at the number that is being multiplied to x squared, the a term, and because it's negative, I know that this is opening down. Okay, what about the x-intercept? To figure that out, I need to try to factor. It turns out it is not factorable. That does not mean that it's a floating parabola. It just means that it does not factor to a whole number. So for now, we're just going to leave it. What is the y-intercept? Y-intercept is the negative 3, the constant value here. So it's 0, negative 3. What is the vertex coordinate? The x is going to be negative b over 2a, and substitute my values and you get 2. And then from here you substitute that into y and you get y to be 5. And the line of symmetry is going to be that x is equal to 2.